Hi everybody, my name's Eli, and today I'm going to be showing you how to show process data, IO-Link process data to be specific, from a Series 4X button. And to do that, I'm going to be using a IO-Link level sensor. You can use any IO-Link device of your choosing, a time of flight sensor, a level sensor like this one. Anything that has process data can be displayed on this. And I'm also going to be using the SIG 200 by SICK. This thing has its own ladder logic built into its software, so it's really easy if you wanted to just make a simple display on your machine. Just slap one of these things on there and it takes only a couple minutes to program it.
So to get started on programming our buttons via the SIG 200, you need to download the SOPAS engineering tool. I highly recommend checking out SIG's website and their YouTube channel for resources on setting this up. And what we can do is we can log in, click into it. Oops. And now that we have it open, you can see the layout of all the ports and your connected devices. Right now, we don't have any connected devices. You can also go to identification and look at firmware. And if we go to IO-Link ports, give it a second to load, we will see all the ports that we have access to and your IODD repository. You can manually download the IODD files for our buttons or whatever IO-Link sensor you might have from IODD Finder or our website, and you would just click this upload button and select the IODD file. Usually they're in a zip file. You just click the zip file. So today we're going to be working with our Series 4X and our Orca sensor. And I've already uploaded the files for them. And this is where you would select your IODD file. And then you just want to click apply. And then you go to IO-Link devices, and if you give it a second, it should load up. It's not exactly right. Let's check this one. Yeah, this is what I should be seeing. There we go. So from here, you can see the two types of IO-Link process data. We have input and we have output. Input is sensor data. So for example, the actuation count, the actuation strength, surrounding brightness. Some of the bytes are unused here, and then you have your different pins, actuation flag. So if I just press the button, you should see this update momentarily. And in output data, this is where our TRM comes into play. If I pull up the TRM. I'm just going to drag this right over. And we scroll down to the process data. So for example, we have the input process data and then the other kinds of process data. And we'll go back to that in a minute. I would like to show you how to configure these buttons. So just go ahead and open all of these. Starting from the top, we have the sensor mode. You have three options here: toggle, dynamic, and static. Toggle being whenever the button is actuated, it will keep the scene that it is on until you press it again. Dynamic, it will exit the scene that you are on when you press the button, no matter if you keep holding it. In static, being when you press it, it will stay until you let go. Also have other settings like touch sensitivity, minimum actuation time, output activation delay, and then going into I/O, we have a couple options here: the 5-pin mode, 4-pin mode, and 3-pin mode. To be honest, I always keep it on 5-pin mode. Every button is a M12 5-pin, but depending on if you're using your pin 2 and pin 4 and pin 5, you don't exactly need 5-pin mode, but I usually just keep it on there. Never know what you need. And then you're able to change from NPN or PNP, normally open or normally closed. Moving on to LED control mode, we have three options: automatic scene selection, scene controlled by iLink process data, and advanced. Automatic scene selection is just the scenes that you program down here, and the way you switch those scenes is by touching it or not touching it and using your output pins. The scene controlled by iLink process data is used when you want to change scenes from the PLC, or in our case, the IO-Link side, so we can program these buttons to, for example, show process data and switch scenes when we tell it to from our logic. And advanced control is the exact same thing, but it gives you more freedom to control, for example, the LEDs. You have to activate each LED manually, and a couple other settings that I will get into on the TRM. You also have adaptive LED brightness and the manual. You can also rotate the button. I find this very useful because, for example, the other day I accidentally mounted a button upside down. I just flipped it 180 and I was good to go. And we also have our custom colors that we can program ourselves. So if you're looking for a specific color, you get 2 of them. Moving on to timer functions, we have a few settings here: count up infinitely, count up, count down, and you set them based on the scene that you want it to go off in. So for example, if I wanted to set a timer on scene 0, so when it's not actuated, so if I'm actuating it and then I let go, when I'm entering scene 0, I will start the timer function, and you're able to give it different colors and different effects. So scenes are every possible input that you can give the button. So for example, no touch, E1 off, E2 off. That's just when you're not touching it and those output pins are off. Scene 1 would be touch, and you can just move down. Scene 2, no touch, E1 on, E2 off. And in the scenes, you're able to individually select the colors, including your custom color and all the LED effects, and the effect frequency and text. For this tutorial, we will not be using the displayed text because we're going to be displaying process data, and that is done on the logic side of things. And if I close all of these, you also receive a diagnostics and observation menu. And now to explain a little bit more about this LED control mode, I can open up the TRM and you'll see our different options. For this tutorial, we are going to be using scene controlled by iLink process data. So basically, this is the scene. So we program our scene, and then whenever we want to change to that scene, we need to write to this, believe this is a byte, or is it just, I think it's a byte. So we'll write, let's say if we wanted to change it to scene 7, we would write 7 to this byte. And the TRM explains what each address does. So, for example, what I just explained right here. And display mode, you can use several options. Use text from scene, so what we program on the IODD side, the numbers given. So if I write 1 to here, I have displayed number right here, and it will display whatever I address to this. Digits given, digits given. So if I write a 2 here, then I have these bytes to work with. So if you wanted to, let's say, program output from your PLC and you wanted text, you could use this. But today we are going to be using number given. And then moving on to advanced, you basically have to program what you would do in the IODD file by using the addresses. So, for example, active LEDs, you have to bit mask each LED to activate them. So this is 2 bytes. So if I wanted to use all the LEDs, I would just have a long string of 1s. The LED brightness and the different colors, the effect frequency, and the TRM lays out all the options down here. Moving back to the SIG 200, we can open our logic editor, and we can see all of our input data over here and our output data over here. So as I talked about earlier, since we have to address the output data as shown in the TRM, that can be kind of difficult. So now that we have an overview of our CAPTRON button and the capabilities using the SIG software, we can start programming. SIG offers some simple ladder logic that allows you to program these IO-Link sensors to do different things, and it works great with our buttons for simple programs that you might use on a machine. So the first thing I'm going to do is actually go back to our iLink devices and make sure that we have scene controlled by iLink process data. So as I explained before, we will send the scene number to the output data LED scene to switch to different scenes. So if I want to go to scene 2, I'd write it to LED scene. So we can go ahead and set up our scenes, and as I showed in the intro, we are going to be programming our level sensor with our button to show process data. So I am going to use LED scene 0, and we're going to keep it red, and we're going to make it why not throbber clockwise, and we can make this really quick. I believe it goes from 1 to 6. We'll go with 5, and since we are going to be displaying process data, we don't want to fill anything here, and we're going to use LED scene 1, and this is actually quite good. We can just do just make it static, and you could do this for each scene up to 7. And now that we have it programmed, we can go back to our logic editor. Oh, I forgot one thing. Our level sensor. Let's make sure that this is programmed. Since it's an iLink device, you also have input and output process data telling us the fill level. And because this level sensor is not in a controlled environment, the data that is going to be outputted here is not exactly accurate. You would need to put this in some sort of enclosure, ground the level sensor, and then calculate the fill level. And you can do that here. I've already done it, and right now it shows, oh, there it goes, the fill level based on our calculations. I just used both of my hands to calculate it for this demo. We're going to go back here, and I think the nicest thing about this ladder logic is you're not like addressing them in bytes. They give you tags from the process data to work with, so it's really easy to just grab certain things. So for example, I'm going to grab LED scene, and I don't need con. I need the pin on the level sensor, which if I touch the level sensor, let's see, fill pin 2. So we're going to use pin 2. It is a 1 when it has liquid, or in my case, my hand on it, and it senses that there is some capacitive, something capacitive touching it. So I'm going to go to S3 pin 2. When it's 0, that means it's empty, right? So when it's 0, it's going to be LED scene 0. When it's 1, it's going to be green, showing that it's filled. And then the next thing we can do is grab our fill level, and LED scene. No, that is not what I'm looking for. I'm looking for displayed number. And I can try to make this look a little more pretty. Oh, and the last thing we need is the display mode. So if I reference my TRM again, I will see that I need to write a certain number to it. Just give me 1 second to pull this up. Oh, where did it go? There it is. So, take a sip of coffee, and we see this display mode right here. Looks like I need to write a 1 to it because it displays the number set and process data output displayed number, which I used fill level to write to. So I can just take a con, write a 1 to it, and I'm going to get rid of this, and boom. We are done programming this level sensor. And there's a lot more you can do here. I wanted to show a simple application of our 4X buttons showing the process data. And you can use delays, timers, conditionals. There's a lot you can do with this software with our buttons to really maximize what they can do. And yeah, that's it.
So after we program using the SIG200 software, we have process data on our puck whenever there is something touching our level probe. And this would be really useful for operators without having to buy an expensive HMI just to see, for example, how much oil is in a tank or how much liquid. But there's a lot of use cases here, and I wanted to show it off. So if you like this content, make sure to subscribe. We're going to be releasing videos monthly. Thanks.